Dear students, through this lecture you are going to study about the fourth type of network parameters known as hybrid parameters. Okay, so in this parameter, we are going to represent the input voltage V1 and the output current I2 in terms of the input current I1 and the output voltage V2. Okay, so I am repeating, the input voltage V1 and the output current I2 is represented as functions of the input current I1 and output voltage V2. And the equations for the hybrid parameters are given by V1 is equal to H11 I1 plus H12 V2 and I2 is equal to H21 I1 plus H22 V2. Okay. In matrix form, I can write the vector V1 I2, that means the input voltage and output current, that is equal to the matrix H11, H12, H21 and H22 into the vector I1 and V2. Okay, so as in the previous case also, in order to find the corresponding values of V1 or corresponding expressions of H11, H12, H21 and H22, either you have to make I1 as equal to 0 or V2 as equal to 0. So first case is I am making V2 as equal to 0. V2 as equal to 0 means your output port is short circuited. Okay, V2 is equal to 0 means output port is short circuited. If V1 is equal to V2 is equal to 0, I can write the first equation as V1 is equal to H11 I1, and from this equation I can solve for H11 is equal to V1 by I1. So we are obtaining H11 is equal to V1 by I1 by making V2 is equal to 0. In the same condition, if I am having V2 is equal to 0, the second equation leads to I2 is equal to H21 into I1, and therefore I am getting H21 is equal to I2 by I1 at V2 is equal to 0. Okay, so this is the first case when I am short circuiting the output port or I am making V2 is equal to 0. Then the second case is I need to make the input port as open circuit. So input port as open circuit means I need to make my I1 as equal to 0. So my input port is open circuited. If my input port is open circuited, then I have the first equation as V1 is equal to H12 V2, and from this equation I can solve for H12 is equal to V1 by V2 at I1 is equal to 0. For the same condition, the second equation is given by I2 is equal to H22 V2, and from this I can write H22 is equal to I2 by V2 at I1 is equal to 0. So if I am making V2 is equal to 0, I can solve for H11 and H21, and if I am making I1 is equal to 0, I can solve for H12 and H22. Actually, H11 is the ratio of voltage to the current in the port 1, and therefore it is actually the impedance at the port 1. It is the impedance at port 1. Okay, now the second is H21. H21 is actually the ratio between the current I2 and I1, and therefore it is actually the forward current gain. It is the forward current gain. So in the first case, I am getting H11 and H21, and H11 is the impedance at port 1 and H21 is a forward current gain. Now for the second condition, if I1 is equal to 0, I am getting H12, that is actually equal to V1 by V2 at I1 is equal to 0, and this is actually the reverse voltage gain. Reverse voltage gain in the sense actual voltage gain is V2 by V1. V1 by V2 is the reverse voltage gain. So this is the reverse voltage gain. H12 is the reverse voltage gain. Now what about H22 is? H22 is actually I2 by V2. So what is I2 by V2 is, you know, the ratio between current and voltage is the admittance, and I2 by V2 is the ratio of the current and voltage at the output port, and therefore it is output admittance. Okay, so hybrid parameters means we have a ratio of impedance, then admittance, then current gain and reverse voltage gain. Therefore, it is a combination of all the ratios and it is known as the hybrid parameters. Okay, since hybrid parameter or H parameter represents dimensionally an impedance, an admittance, a voltage gain and a current gain. These are known as hybrid parameters. Okay, so that is a theory behind hybrid parameters, and you can draw equivalent circuit corresponding to the hybrid parameter. Equivalent circuit of a two-port network corresponding to hybrid parameters. So I am repeating, the equation is V1 is equal to H11 I1 plus H12 V2 and I2 is equal to H21 I1 plus H22 V2. So here, if you are analyzing, if you are having the two-port network, you will be having the input voltage as V1 and input current as I1. Okay, so if you are analyzing, in the input, at the input side you have V1 and I1, and H11 is actually the impedance, and therefore I can draw like this. If I have the impedance H11 at this point, then the voltage at this point will be, voltage across this will be H11 I1, and you will be having the another parameter H12 V2. Actually H12 V2 should be represented by a voltage source, because it is having a parameter voltage that is multiplied with H12, and that is representing a voltage, because this equation is representing a voltage equation. Therefore I can draw H12 V2 as a dependent source that is depending upon the output voltage V2. So this is actually H12 V2. Now what about the output port is, you will be having the output port with the voltage V2 and the current flowing through it is I2. Now the second equation is actually representing a current source, current equation. Current equation in the sense H21 I1 is a current and H22 V2 is also a current. So how I can solve for H21 I1 is actually the current that is flowing through port 1, and H21 is a constant, and if I am multiplying H21 with I1, I will be getting I2. That means it is representing a current source that is delivering a current equivalent to H21 I1. And what about the next case is, you will be having a voltage here and you will be having H22. H22 is actually I2 by V2, that is, it is an admittance. So admittance into V2, you will be getting the current. That means you will be having an admittance here, whose value is equal to H22, and H22 into V2 is the current that is flowing through this thing. Okay, so input is represented by a, or first equation is representing the voltage equation, and that is equivalent to the input current I1 into H11 plus the dependent voltage source H12 into V2, where V2 is the voltage at the output port. On the output side, you will be having the voltage as V2 and the current as I2, and the second term of the current equation H22 V2 means, if you are having the voltage V2, then if you are multiplying that V2 is an admittance, you will be getting a current. Therefore I can connect H22 as an admittance, and the first quantity is H21 into I1. That should be a current source, because you are getting the current equation. So I am representing that as a current source, that is a dependent current source depending upon the input voltage I1. So this is actually this diagram is representing the equivalent circuit of a two-port network in terms of H parameters. Okay, thank you.